Well, it's time for an actual how-to video, not a crazy update, but an actual how-to video. So for my first video back, I wanted to revisit some older content where I made a block mold with some vents, but I'm going to go over that a little bit more and explain some more options that did not exist back when I made the original video. Now, and just for those just joining us, I'm in my new studio. Still getting the old tools and things unpacked and the shop decorated to my liking, but slowly but surely it's getting there. So in the next few videos, you'll start to get an idea of the new shop environment. So if there's interest in that sort of thing, I'll be glad to give a virtual shop tour once things are kind of settled. But the video at hand, I'm going to show how to make a mold with vents. And the whole point of putting vents into a block mold is to facilitate the flow of resin and to allow the air to escape out in front of the flow of resin. Now, on a straightforward part like this little chest piece here, this little pawn, when this little guy is cast, pretty simple. You pour the resin into the base and the air will automatically just come right up, because there's so much room in the opening of the mold to allow that air to trade places with the liquid coming into the mold. So overall, pretty simple. The only troublesome spot here is just making sure this little lip right here doesn't trap air bubbles, but that's another video for another time. But something like a screwdriver or a knife blade or a thin-walled part, especially when the thin-walled part comes to a dead end like this. What happens is when we're casting in, say, through the handle up here or the handle of a knife or what have you, and then that resin travels down here where it dead ends in that small point, there's not enough hydraulic pressure pushing down on a smaller cast like this to get that air out. And that air is trying to go up and out the same way the resin is coming in. So that of course creates a problem because again, if you're pouring really thin walled parts and you don't have a lot of downward pressure, a lot of hydraulic pressure up above, then you could wind up with a void down here at the tip of your knife blade or your screwdriver tip or whatever. So anytime you're casting thin-walled parts, especially where they come to an edge or an end like that, that's a problem. So what we're going to be doing in this video is showing how you can take a vent from that point and reroute that air out and up the top of the mold. So that way, as the casting material flows in, the air flows out. And that's the whole point of a vent, is to allow the resin to go in and the air to go out. So your vents can be very small, they just need to be large enough to allow that air to escape. Now for this video, we're going to be molding a prop knife. And the reason I chose this knife for this pattern is obviously we have a lot of prop making customers, but also a knife is especially tricky just because you have a large handle, but not so large as to create a lot of hydraulic pressure, but then a really thin blade. And then, even more importantly, that thin blade comes to a point. So that's what we'll be addressing in this tutorial. Now, this is a pretty standard block mold like we've done in previous videos, so I'm just going to be using some foam core board that I've scored, and I'm breaking those lines into a rectangle box. You could also use MDF if you're making a larger mold that might have more pressure. And then we're going to release the inside of this box with Zip 301 mold release. Now I originally used Eject-It 33, but Eject-It 33 sadly does not exist anymore. So Zip 301 is the replacement for that product. Now I mounted the knife to a piece of plastic board. You could obviously use additional foam core board or MDF, but I mounted that with some hot glue, and then I used a spare piece of aluminum grounding wire just bent to make that main vent shape, and then a little coffee stir to make that other vent. And you'll see that all of those vents attach to the high points of the model, all the areas that dead end, so to speak, that might trap air. Now once again, we're going to release our pattern and our vent system with more mold release. And again, Zip 301 is the release we want to use anytime we're going to be making a silicone mold. And now ready to close up our box around our pattern and secure everything in place. And to do that, we're going to be just wrapping that foam core box. You see how I've scored it and then broken it along those lines. And now we're going to fold that up into a rectangle box and then secure that with hot glue. And I want a clearance of about 1 inch all the way around that pattern. So we want to make sure that we have plenty of clearance, because ultimately we'll be cutting that mold open. And I'm going to go into that a lot more in detail later in the video, but you want to make sure you have plenty of allowance for that cut, because we're going to be making a keyed cut where that mold comes apart into 2 halves. And it's imperative that we have enough room to cut the mold and create a keyway as we're making that cut. So again, more about that later. Now we're going to slip that down over our knife and then secure that with more hot glue. Now this arrangement works great for a lot of small to medium sized molds, but when you start doing really large molds, sometimes it's a good idea to use a different material, like an MDF box screwed together, or a melamine coated plywood screwed together. But just remember, the amount of silicone or rubber, whatever type of rubber that you're going to be pouring your mold of, that will determine the weight and the hydraulic pressure that's on that mold box. So if you're making a really large mold, foam core is not a good choice. But if you're working in smaller to medium sized molds, foam core works fantastic. Now, in addition to securing that with hot glue, I'm also going to seal up that base with some extra sulfur-free clay. Now, here I'm using Protolina clay, and Van Aken, that makes the Protolina, also makes a sulfur-free clay called, I believe it's Plastilina, that's available in a lot of hobby stores. But either one of those works great. They're just soft, inexpensive modeling clays, and most importantly, they're sulfur-free. So they work great for sealing up mold boxes, and then you just keep a big ball of that clay on hand anytime you're going to be making a platinum silicone mold. Now, once I've got that all sealed up, I'm ready to mix and pour my silicone. But first, we need to choose which silicone that we're going to pour for this. And we have several considerations with a mold like this. So let's go over our options. Now, for this, I wanted to highlight the BJB 1:1 ratio silicones. These silicones, a lot of these came onto the market after I made the original video, so I just wanted to go over some of the options. On the very soft end of the spectrum, we have the 0025, the 5100. That is very soft, like your earlobe. Then we have 5110, which is a little bit firmer. It's about a 5A. That's a really good approximation of skin for medical simulators and that sort of thing. Then we have 5130, 5140, and 5150, which is very firm. Now for this, I'm actually going kind of medium. We're going to go right in the middle with the 5130. So if 5130 is about a 25 short A, and it's ideal for this. And one of the considerations is we don't want something so soft that when we put those 2 halves of the mold back together, they distort where they're compressed at that seam. Now, we also don't want a rubber that's too hard or too firm, because if we have something really firm like 5150, trying to pry this open to make the really intricate cuts we need to make will be very hard to do with a really hard silicone. So 5130 is the ideal choice. Now, here's another consideration. Again, since we made the original video, they came out with 5130F, which F is for fast. So now there's a couple of options. We have 5130F, which is an 8-minute working time and about a 1 to 1.5 hour demold. And then, of course, we have the 5130, and that's what we actually used when we shot this video. That has a 30 to 40-minute working time and a 3 to 4 hour demold. Now, both of these formulas have a very low viscosity of around 5,400 centipoise, but because this is a larger mold, I would really recommend for larger molds like this to use the 5130, just the regular formula, because we're going to need that 30 to 40-minute working time to make sure we can pour this fairly large mold, and we have plenty of time to vacuum degas and get a good pour. Now, in the interest of time, I'm going to go kind of skim over some of the mixing and pouring process, but the main thing I wanted you to see here is that I'm pouring this in 2 batches. This mold took about 9 pounds of silicone. So what I'm doing is I'm breaking this down into 2 separate batches. I'm going to do half of this in one bucket and half in a separate bucket. And the reason for that is we need enough room in those mixing buckets to vacuum degas both of those batches. So I want to make sure that I have plenty of room in each bucket to mix the silicone, and then once I subject that to a vacuum, it's going to expand, and we don't want that overflowing out of the bucket. bucket. So really, we could have fit 9 pounds in one mixing bucket, but we would not have been able to pull a vacuum on that. So that's a really important consideration when you're going to be vacuum degassing. Make sure that you have enough room to vacuum degas and have that silicone expand and collapse within that mixing bucket. So here I'm just measuring out my parts B into the 2 separate buckets, and then I'll add my part A and mix that all up. So again, real important to remember that little trick. Sometimes it makes sense to do multiple batches, and that way you can vacuum degas everything in a regular size vacuum chamber, because my vacuum pot will handle, it's about a 2.5 gallon chamber, so it will handle a gallon bucket fairly easily, but not many of us have access to a vacuum chamber that can vacuum degas a 5-gallon pail. So important consideration. Now remember, when you add your part A or your part B, once the 2 parts go together, the clock starts ticking. So that's when your working time starts. As soon as the parts A and B go together, that's when you need to start that countdown. So just remember that as soon as that starts, you need to get moving. Now the other really important detail to remember with your working time is that hot weather or hot shop environments will speed up your silicone. Cold environments will slow it down and even inhibit the cure. So make sure you remember that. If you're working in a really hot area, I recorded this in Texas in the summertime, so sometimes that could cut your work time in half. So be aware of that, that all the numbers on the manufacturer's data sheet are for room temperature, which is typically about 70 to 75 degrees Fahrenheit. Now I'm pouring the silicone into the mold box, and I'm just picking one spot down at the bottom of the box and letting that silicone flow upwards. I'm just pouring in a steady stream, and again, this has been vacuum degassed. So you see we have nice bubble-free silicone. And again, that's a nice low viscosity, so that also helps us minimize air entrapment. And this is the second batch we're pouring. And one of the things you'll notice, a few little bubbles in there, and that's okay. That's actually right after I pulled it out of the vacuum chamber. Those all dissipate. So sometimes you see that, especially in more humid weather, you'll see some of those little bubbles appear even after you vacuum degas. But it's the weirdest thing. They all go away once everything is poured. Now, we want to make sure we pour this well within that working time. And then again, this has a 3 to 4 hour demold at room temperature. So we let this sit. I went ahead and let this mold sit overnight. And this is the following day. We're ready to open that up and cut open our mold. Now, this is a pretty straightforward mold to open, but on molds that are a little bit more complicated, sometimes what I'll do is I'll write instructions on the outside of the box, especially if I'm making the mold in a shop where there's a lot of people working and someone else might be opening the mold. I'll put instructions on the outside of the box and say, put seam here or don't cut here or anything like that, so that someone doesn't accidentally cut a mold open in the wrong spot, ruining the mold. Now, cutting open this mold, this is a little bit of a tricky process. I don't want it to sound harder than it is, because overall it's pretty straightforward, but you definitely want to make sure that you go into this with a clear plan of how you're going to open this mold. Now, what we need, as I mentioned earlier, we need this mold to have a keyed edge where the 2 halves of the silicone are going to mate together once the mold is completely cut apart. So we want to make sure we're not just making a straight cut and then putting that back together, because then we're going to have a very high probability of misalignment. Now, once we've cut away any excess silicone, any of those edges that got some little drips in the foam core, we're going to cut that away. Now ready to do our cut into the part. Now the first part, this is where things get tricky, is the first thing we're going to do is create what I call an S-cut all the way around the perimeter of the mold. And that S-cut area doesn't go all the way to the part. So we're not having to even worry about getting to the part right now. We're just making that S-shaped key cut all the way around the perimeter of the mold. And we do want that to line up roughly with where that mold's going to cut in half, but we're not trying to cut the mold in half yet. We're just going all the way around the perimeter, making that S-shaped cut. And that's what will give us our alignment later on. So when we open that all up, ultimately, when we have that 2-piece mold, that S-shaped cut that you see right there, that's what will give us our keyed edge that will go together. Now, the second cut that we're going to make, And this is where this is definitely a two-man job. We're going to make a straight cut from that point into the pattern. So the rest of that mold goes straight down to the pattern. And that's where things get a little tricky, is now you're going almost a funnel shape. You're going from your S-shaped key, and then you're going down to the part in a straight line. And the reason we're doing this is if you just made that S-shaped cut all over, for one thing, on a part with a straight edge, that S-shaped cut terminating right into the part is going to look weird, because now you're going to have a weird S-shaped seam that runs all the way around the part. So you don't want that. So ideally you want a straight seam where it meets your pattern. Now, the other important detail that's hard to see in video here is what we're doing is we're actually cutting up from that knife blade and cutting up to that S-shaped cut. So once we get that all the vents cut out, and here I'm just going to go ahead and pull out the knife. What we're doing is actually taking that scalpel and cutting from where the knife was, the space where the knife was, and I'm cutting upwards from that area to meet the rest of that cut. And the reason that's an important step is on a part like this knife where you have a really thin blade or really thin cross-section part, is if we're trying to cut to that from the top, we could easily miss it, and then you have to go fishing for it and cut 3 or 4 or 5 different times, and that's going to make your mold just full of different random cuts. So to make that a lot cleaner, sometimes it makes more sense to go in from the thin part of the cast and pull the blade back to meet the rest of the cut. And now we have our mold cut in 2 halves, and you see that nice S-shaped key gives us a nice alignment on our part. And now we are ready for casting. Now, this is a pretty simple part and a fairly simple mold, so I'm just going to secure this with some electrical tape. But depending on the geometry of the part and what you're going to be casting, sometimes, especially if it's going to be a foam part, it's a good idea to make kind of a sandwich of your mold with some MDF board on each side of the mold as a backing for that and a support for that. But again, pretty simple part here. So I'm just going to mix up a small batch of TC808 jet black resin. And this is mixed 1-to-1 by weight. An interesting thing that I've learned about TC808 and other products that start with TC, TC stands for 2 components. So you just learned something that you didn't know before. Now, TC808 has a working time of about 2 minutes, so we want to get this mixed and poured as fast as possible because, again, remember, this is at room temperature. We have about 2 minutes, so you want to move fast, get that stirred up accurately, and poured. And now for our vent system. Now, if everything goes in accordance with the prophecy, what happens is when we pour into the main body of that knife, into that handle, the resin will flow down and the air will flow up. So we get a nice circulation where we don't have any dead ends, and that allows the resin to completely fill the part. So now we can still subject this to pressure. So if we have a more complicated part, once we're done with our pour, we could subject that to pressure about 60 psi and get a nice bubble-free part. But for the sake of this video, we're just going to pour this without any special pressure or anything like that. This is just a regular room temperature pour, and I just want to do this so you can see what that vent system will do without any special efforts. Now, TC808 normally has a demold time of about 10 to 20 minutes at room temperature, but I went ahead and let this sit for about an hour and a half. And the reason for that is, remember, when we're doing something like this knife with a really thin cross section, you want to give that more time to cure, because these resin systems like this, these cure in the thickest areas faster than the thinner areas. So just remember, anytime you're casting a thin-walled part, you want to give that plenty of time to cure. So sometimes you want to let that sit in the mold for an extra hour or so. Now, when your vent system fills up with resin like this, that is a good sign. That means it worked exactly the way it's supposed to. So now we're ready to demold our part and carefully remove that vent system with a scalpel or X-Acto knife. And TC808 cures to about a 78D. So this is a nice, hard, tough resin. And the nice thing about this is, even though it is a very hard resin, it's not brittle. So this is ideal for prototyping parts that need to simulate like ABS plastic and things like that. Now, this is the point in the video where I typically direct you to our website, but instead I'm going to send you to the video description, and I'll put links to the products we used for this video. So both the silicone we used as well as the casting resin. So be sure to check that out. And if you haven't already, be sure to like and subscribe, and feel free to comment with any questions you have about this process.